Welcome everyone. I am Ujjwal Pal. Today we will solve a LeetCode problem step by step. The problem number is 1653, which is minimum deletion to make string balanced. Let's see the problem description. You are given a string S consists of only characters A and B. You can delete any number of characters in S and make S balanced. A is balanced if there is no pair of indices ij such as like I less than j and s of I will be b and s of j will be a, which means there will not be any a on the right side of any b. Okay, and find the minimum number of deletion needed to make s balanced. Let's see the constraints. Constraint says the length of the string will be up to 10 to the power 5 and s of I will be only a or b. So we will use dynamic programming here. So I will show you the memoization way to solve it. So there is like for to solve this problem in by memoization algorithm, you have two options. Like for each index, you can take it or not take it. Okay, and the another thing is if you are taking or not. It depends on the previous character you have visited. Like if the previous character is A, then you can take it or not take it. And if the previous character is B, and then you can take it or not take it. Okay. But there is a condition. Like if the previous character is B and the current character is A, you cannot take the current character because of this condition. There will not be any A after the first B. Okay. So that is the only one condition we have to check, and the rest of the thing, the recursion will done automatically. Let's see the memorizer. So first we need to create the DP to keep track of the like if the previous element is A, then and if previous element is B, then we need to keep track those two answers for each of the elements. So we will create first a vector in, let's say, dp is dot size will be the size, and each index will be content will be 2 because for previous element a and previous element b. So 2 will be the size and initially it will be -1, and return we will create a helper function. We will pass s dp current index which is 0, and let's say the size which is h dot size, and previous element for the first iteration the previous element will be -1 because there will not be any left side any character if it is the first element. Okay, so let's see the helper function which will look for int helper. First is string. To optimize the space, we have to use the reference of the string and also the reference of the DP. The DP must be reference, okay, because if we change any of the value in DP, it should reflect in all the functions, all step. So reference in I is the current index, int n is the size, and the previous element, let's say 3. So first we will check if I is equal to n or not. If it is, then we just return 0 because we already exceeded the length of the string. Then that means the s is balanced already, so we will just return 0. And if it is not equal to -1, and p not equal to -1 means there is at least one character left side of the current index. and dp of I pre is not equal to -1, like it is already calculated. Then we just return the calculated value. Okay. So it will be the calculated value. And after this, we need to uh, find two conditions, which is take and not take. Like if we take the current element and if we do not take the current element, we have to check that and we will return the minimum element. Okay, so first I will check the two not take. No take. Let's say no take will be alpha s dt I will be I plus 1 and n will be n and previous will be same. It will be no take. And I already told you if the previous element is B, the current element is A, so we have to like delete the current element. We do not need to like add the current element. We cannot add the current element. So if a previous equal to 1, let's say I told you like previous, let's say writing previous could be three things, either -1 or 0 or 1. -1 is for it if the current index is the uh, first element of the result string, then it is -1. 0 means the previous will be A. Okay, the previous character is A of the current uh, element. Previous we have visited A, and if 1, then means we have previously visited B. So this could be the three values of 3. And if the previous value is 1, that means previous we have visited the B, then and current index means s of I is equal to A. Then you do not need to just return uh, store in one line also in degree of I and 3 equal to just nothing, because we can't take the current element which is there because we already visited V previously. So according to the condition, we can't take it. So after that, we have to calculate the next previous, which is let's say next to P equal to, we check if S of I equal to A or not. If it is A, then the next previous will be 0 and else 1. Okay. Now we will check in take. If we take also, if you are not taking anything here, you have to add 1, because to exclude the current index, we need one operation. So please add 1 here. And if we are taking, then helper of s dp I plus 1, n will be n, and previous will be next t. Okay. Now we have taken non-take person. So we'll check if it is not equal to, let's say equal to -1. That means this is the first index, this is the first element of the resultant substring only. Okay, this is the first time we are traversing. No previous element there of the current element. So we just need to return the minimum of take and make it, else we return along with storing the data today equal to same as this. Okay. We are checking p equal to -1 because dp of I p, if p is -1, it will give an error. That's why we have to check it first, then we can return it. Okay, that's it. Let's see, is accepted. Let's submit it. if it is accepted. Let me discuss the time and space complexity. So the space complexity, we are creating a DP of size n cross 2. So you can say n cross 2 as n if you are using big O of n. So the space complexity will be big O of n. Okay, and the time complexity for each of the value of pre, it will this loop, it will traverse big of n times. Okay, for minus 1, it will check each element that this is the first element, and if 0 for 0 also, for 1 also. So the overall time complexity will be big of 3 into n, or you can say big of n. So time and space complexity for this memoization algorithm, both are big of n. And you can also uh, do it the memoization in tabulation form also by using a for loop, and but the time and space complexity will be the same. So I am not uh, going to show you that, but I will show you the optimized algorithm. So in optimized algorithm, what we will do, we will keep track the answer. Answer means the minimum number of deletion needed to make the last string. Like if we are standing in position k, so to make the string like 0 to k minus 1, we have an answer already calculated, and we keep track also the number of bees we have encountered till now. Okay, and what we will do, we check if the current element is a, then we calculate the answer again. So what we will do, how the answer will be calculated, we first check if we exclude the a, which means the last answer till now, plus 1 1, because we are excluding a. So we will check that is it minimum, or number of bees we have encountered till now, we will exclude all the bees, okay, previously. So which is minimum, the minimum will be the answer. Okay, let's see, we will understand if you see the code. So we need an answer which is initially 0, and in cnt is the count of b. Okay, and we will traverse in not to 0, less than dot size I plus plus, if the s of I is equal to b, then just cnt plus plus, else we need to calculate the answer. Answer will be, already said it, I already said it, answer will be max of a minimum of previous answer plus 1, because previous answer plus 1 means we are excluding the current a. Okay, or the till now all the number of like bees we have encountered. Okay, either we exclude all the bees, or till now the answer plus 1 means the current a element. Okay, whichever will be minimum, we will keep track of that. That will be the answer and return the answer. Let's see, let's submit it. So it is accepted. So the time and space complexity of this algorithm, you can see the we are using only one for loop, which is traversing from 0 to the length of the string. So the time complexity is big of n, and the space complexity, we are not getting any of like array or list, which is depending on the size of the string, just some variables. So the overall space complexity will be big of constant, or you can say big of 1. That's it for today. See you in the next video.